All right, hello everybody. This is Mr. Gubino here. We're going to be finishing up angles in circles. So you have the notes from today to download or look at. I am going to be going over page 3 first because I think that's kind of easier, and then we'll go back through. So if you see the formulas first, and then we go back through and we can look at them, okay? And it's pretty self-explanatory. You just have to follow along. It's kind of like a flow chart. You find the one that works, and then you plug in the arcs. Okay, so we're going to go over that. Couple wrap-up things. Make sure that you're emailing me if you need a rise of your grade for semester 1. If you haven't looked at anything on here, then we'll see what happens with that. So let's just kind of go right into it. Let's get started. All right, so this is the note packet, and you'll see that there's other angle relationships. We've discussed central angles whose vertex is in the center. We've discussed inscribed angles, which are angles whose vertex is on the circle and whose sides are made up of chords or secants. And now we're going to look at other ones. So we're going to go directly to page 3, or page 3 or 4, one of those two. It's this one. All right. So circle angles, and I kind of gave you a hint on each one. So the first one we've done. Okay. So if the vertex is the center of the circle. All right, so if the vertex is the center of the circle, these are central angles. The central angle, the measure of arc AB, this arc is going to be the same as this measure. The arc BC is going to be the same as the measurement of our angle 2. Now, I know that one doesn't look like the center, but trust me, it is, okay? So if the angle here is 50, then this angle is 50, which would make this 130. Let's do it in green here. So if that's 130, then this is 130. Okay, so that's a central angle. So these are your central angles. And they're the ones that have the vertex in the center of the circle. Okay. We're going to go to inscribed, which is down here. Okay. So this is your inscribed one. And we just did that last Wednesday. And this inscribed one is going to be half of the arc intercepted. So this angle, it is a central angle because it's on the vertex. This arc that is formed right here is half of the arc is the measure of the angle. So if this was, let's say, 70 degrees, then this is half of that, which is 35 degrees. So the angle is always going to be half the intercepted arc. Reminder, these are intercepted arcs. We are going to be using intercepted arcs a lot today. So if you notice, there are 5 more things. So let's go with the vertex on the circle. So this is made up of chords. This is made up of a chord or a secant and a tangent. Now, if the chord and the tangent, if the chord was a diameter and a tangent, those two would be perpendicular. But in this case, the measure of angle 1 is going to be half of the intercepted arc AB. So it intercepts the arc. Now, it really, the vertex, since it is on the circle, intercepts that arc. So if that's my angle, my intercepted arc is this part right here. Okay, so there's my arc AB. and the angle is going to be half of that. So if you notice, if your vertex is on the circle, your angle is going to be half the arc. If you want to look at it another way, your arc is going to be 2 times your angle. I'm just going to multiply by 2 over here. So you can look at it 2 ways. You can do arc equals 2 times the angle if you're given the angle, or you can take the half the arc and get the angle. So angle 2 would be half of this big arc because it hits here and this angle. So if this was, well, we're going to come up to the example of 100, which would make the other part of the circle 260 degrees, right? So a full circle goes 360 degrees. Half of this is going to be this angle, which is going to be 50, and half of this is going to be 130. Well, if I know that those two add together, those two added together should be 180 degrees. This is a linear pair. This is your linear pair. So this is, if I took the circle away, and I had 50, this would be 130. Now if I include that circle, oh, okay, well, let's draw the perfect circle. Look at that perfect circle. This is going to be 100 from this point, from there to there, and this is going to be 260 from there to around to there. Okay? So if your vertex is on the circle, your angle is half the arc, or your arc is twice the angle. Okay? Let's reverse back to the vertex. Let's say the vertex is inside of the circle, which is not the center and it's not on it, someplace inside that circle. Well, the angle that you're finding is going to be the average of the intercepted arcs. Average. You've heard average before. It's the sum divided by the total number of objects. So in this case, there's 2 arcs. We're going to divide by 2. Average. If you have an 80 and 100 on your test, the average is 90. Add 80 and 100 to get 180, and then divide by the number of tests you had. If I had the average of my students in my 4th hour, average age, I'd add all the ages up of the students, and then I would divide by 30 because there's 30 kids in there. Or add up for my 6th hour 29 kids, divide by 29. That would be my average. So it's the average of the intercepted arcs. We've heard intercepted arcs before. This is where a colored pencil might be useful. So intercepted arcs. If I look at angle 1, okay, angle 1 is this angle right here. I want to know what the measure of this angle is. Well, we also know that it's going to be the same as this angle, right? Because they're vertical. Right. So what we're going to do is we're going to take arc AD, which is this arc, from there to there, and we're going to add arc BC, which is right here. Now, it's those 2 arcs because since 1 and this angle are equal, these are the 2 arcs that are intersected by those angles. Okay, so if your center is inside the circle, not the vertex, you're going to take the average of those 2 values. So if you look at angle 3 is going to be this arc plus this arc. Now they might be major arcs, that's fine. I'm not worried about that. But those 2 arcs are going to be the same. So we'll come up to a couple examples of that. So vertex on the inside, not the center, is the average of the arcs. So basically what this translates into is arc plus arc. Oops. Arc plus arc divided by 2 or times 1/2. So the angle is 1/2 arc plus arc. Okay? All right. So vertex on the inside. Here we go. Vertex outside of the circle. Now if you notice, here we have two secants. Here we have a secant and a tangent. Here we have two tangents. And they all intersect an arc. And if they all intersect an arc, then what is going to happen is you are going to get angles that are going to be formed by those, and then you're going to have intersected arcs. Now, the intercepted arcs might be a little bit different. I'm just ripping some paper because I'm going to show you here. If I take the edges of the edges of this first one, so let's take a look at the equation that we're going to begin with. So the vertex, which is outside of the circle, vertex outside of the circle, is going to be half of the difference of the arcs. So it's going to be arc minus arc. Now, which one do I take first? Well, what we're going to do is we're going to look at it like this. So here is the angle that is formed, right? Do you see the two arcs that are intercepted? Please say yes. Yes, Mr. Guno, I do. All right, so what we're going to do is we're going to shade those. So it's this arc, nice shading of my arc, and this arc. And what we are going to do is we're going to take CD, CD, which is my bigger arc, sorry, that needs to be green because CD in here is green, sorry. So we're going to take arc CD and we're going to subtract the measure of arc AB. And then we're going to take half of that difference. So you always want the bigger arc here and then subtract the small arc. Because if you don't, if you take the small arc minus the big arc, guess what you get? That's right, negative number. We don't want negative numbers for angles. So we need to have that value there. So let's take a look over here. Where are my two intersected arcs? My two intersected arcs. Here we go. Let's do the big arc with green again. So the big arc is this. Notice it hits right at that point, that tangent line point. And then we're going to take this one. And you notice it hits right at that. So arc addition, that would be the total arc, right? So we're going to take arc AB and subtract it from the bigger arc. So this is your bigger arc. Subtract your smaller arc. And you're going to take half of that. And that's going to be the angle 1. Now, if I give you the angle, then we'll just set up the equation a little bit differently. All right, last one, two tangents. So here's my angle. Now, if you look at two tangents, it has two lines, 2 points of tangency. We have two arcs that are formed by the circle because these points of tangency intersect that circle. So we're going to have this big arc, and we're going to have this arc. Okay, so what we're going to do is we're going to subtract those two. Now, again, I made this one a major arc because it is pretty major. Okay, so again, vertex on the outside. The angle is equal to the difference of the arcs. I'll show you the shortcut for that when we get there. All right, so let's recap. Vertex, center. Central angles, arc is equal to the angle. Vertex inside, not the center. You have vertical angles in there. So what's going to happen is you are going to take the two intersected arcs, the blue and the red, add them together and divide by 2. And we'll go over a couple of those. And then your homework will be that. Vertex on the circle. We've already done this one. Inscribed angles. Here we have a chord and a tangent. Again, angle is half the arc. Vertex outside the circle is the angle is half the difference of the arcs. subtract the big arc minus the smaller arc. Again, big and small. We should probably use major and minor, but sometimes the major and the minor arcs aren't necessarily the biggest arcs. Okay, so we're going to go to the notes here. Take a break, copy those down if you need to. I'll come back to my pretty face here, and we'll come back to that in just a second. Gather your notes up, and then we're going to break down each part of those here in just one moment. All right, here we go. Hopefully you're back. So we're going to go back to the notes, and when we go back to the notes, we're going to be on the front page talking about the breakdown of each of those. So here's the formal definition that might be a little bit more involved than what you're looking at. So if a tangent and a chord, all right, there's the tangent. This is the chord. Remember, a chord is a segment whose endpoints are on the circle. Intersect a point on the circle. Then, oh, this is an if-then statement. So it's a hypothesis. So my hypothesis is a tangent and a chord intersect at a point on the circle, because a tangent has to intersect someplace on the circle, right? So B, guess what B is? Is the point of tangency. You don't need to write that down, but I know you will. All right, so the measure of each angle formed is, so the angle 1 is 1/2. There's your is your equal sign. 1/2 the measure of its intercepted arc. So your intercepted arc. So we did this one before because it was on our sheet. So the measure of angle 2 is equal to 1/2 the intercepted arc. So in this case, angle 1, the measure of angle 1 is going to equal 1/2 arc BC. The measure of arc BC. And the measure of angle 2 is going to be 1/2 the intercepted arc, which is a major arc, CDB. 1/2 the measure of angle, what is that? CDB or BDC. Okay. All right, let's take a look at it in some examples. Okay, so we already did that part. Anytime it's on a circle, on the circle, on half the arc, on half the arc. Okay. So the angle, here's my angle X. X is going to be, well, the intercepted arc goes from B down to A, so that is 1/2 of 156, which is going to be half of 156. What is that, 78 degrees? Perfect. Now, what is y? Well, y we can figure out because it is a linear pair and they add up to be 180. We could take y and take 180 minus 78, which is 102. Now, if y is 102, it makes the major angle double that, or 204 degrees. Let's just check something out. So angles have to add up in this case to be 180. So 102 and 78 add up to be 180. Arcs have to add up to be, that's right, 360. Good. So X is 78, Y is 102. Here's my measurement. MN, if this is a right angle, MN is a chord that is called a diameter. So there's my diameter. All right, so if that's 90 degrees, so the angle is half the arc, or the arc is twice the angle. So 2 times 90 is 180 degrees, which makes the other arc 180 degrees, which makes the other angle 90 degrees. That's right. All right, I got a lot of X's and Y's and Z's in number 3. Let's tackle this one here. So 2x is twice x. Well, x plus 2x has to equal what number? X plus 2x has to equal what number? That's right, 180. So 3x is equal to 180, which means x is 60 degrees. So if x is 60, that makes this angle 120. Now, because I have the angles, the angle twice the angle is going to equal the arc. Twice the angle is equal to the arc. So z, 60 times 2 is 120. And 120 times 2 is, y is 240. Make sure that these two add up to be 360, which they do. Rewind those if you need to. Okay? All right, here we go with the second part. All right, if-then statement. If two chords intersect in the interior of the circle. Interior, not the center. Not the center. These ones we're not dealing with the center. It looks like the center, but it's not. Then the measure of each angle is 1/2 the sum of the measures of the intercepted arcs. Angle is equal to 1/2 arc plus arc. Okay, so what we're looking for is we're looking for arc. So if it's this arc and this arc, then the measure of angle 1 or the measure of angle 2 is going to equal 1/2 the measure of arc CD plus the measure of arc EB. So I don't know what those angle measures are. We could probably guess a couple. Let's just throw in a couple numbers just in case. If they were equal, then that would be the center. So if those two are equal, that's the center. We don't want that. So let's make it easy on us. Let's say this is 50 and this is 70. I know, I'm getting there. So measure of angle 1 or 2 is 1/2. This arc is 50. This arc is 70. So it's 1/2 of 120, which is 60 degrees. The measure of angle 1 is 60 degrees, no matter where I take that. All right. So just for kicks here, what's this angle? Angle 3. Well, I don't want to make this 130. Let's make this 120. And let me get my trusty calculator out because I don't trust my toes and fingers right now. 50 plus 120 plus 70 is 240 subtracted from 360. Can't do that. Okay, so I can't have that. Let's do 100. So 100 plus 50 plus 70 is that, subtracted from 360 is 140. Okay, we can do that. Okay, so measure of angle 3 is going to be 1/2 the arcs added together. Which two arcs are going to be added together? Well, I got my green and my purple here. So my purple arc plus my green arc inside purple plus green. So that's 140 plus 100, which is 1/2 of 240. Oh, 1/2 of 240 is 120. So the measure of angle 3 is 120. And if you notice, measure of angle 1 plus the measure of angle 3 have to add up to be, that's right, a 180. It's amazing what all the extra knowledge that we know, that we've been doing throughout the year, has been paying off. Hopefully, you can recognize how everything is intertwined. All right, so we're going to go to the next page. Let me pause this for 1 second. Let me zoom out just so you can get the notes if you want to pause it. Go ahead and pause it. And we'll be right back. All right, we're back on the next page, sorry. my water decided to sweat itself out on its glass, so it got on my thing. It got on my paper. So, all right. So in this case, we're going to use the underlying principle that the angle is equal to 1/2 arc plus arc. All right. We're given the angle, and this is the arc. We're trying to find the arc. Okay, so we could plug it into that formula. So let's plug it into that formula. So 100 is equal to 1/2 of x plus 135, because the arc plus the arc times 1/2 is 100. What's my first step? Yep, multiplying by 2. Get rid of that half. So we get 200 is equal to x plus 135. And how do I get x by itself? I need to subtract 135 from both sides. So x is equal to, let's see, that's 19. I better make sure that's 65. So x is 65. Just for kicks, 135 plus 65 is 200. Divided by 2 is 100. So what were the steps for me to find the arc? So what I did was I took 2 times the angle and I subtracted the arc, and I will get the other arc. Okay, I can do that too. Sorry, 2 times the angle minus the arc, because that's just manipulation of this formula. If I wanted to solve for this, I would have to multiply by 2 and then subtract one of the arcs. Okay? Just depends on what you're given. So if you're given 2 arcs, got 2 arcs here, this arc and this arc. So x is equal to 1/2 of 110 plus 30. So x is 1/2 of 140, which is 70 degrees. I don't need to know that, or the other angles, or anything else. It's just asking for that angle. All right, here we go. What do those 2 arcs have to add up to be to get half to equal 45? All right, so my angle is 45. I need half of arc 1 plus arc 2. 45 is equal to 1/2 of 3x. I don't want to take half of 3. That's an odd number. So I'm going to double 45. And then, because both of these are in terms of x, I know that this arc is twice the length of this arc. So x is equal to 30. So therefore 2x is 60. All right, let's check it out with the formula. If I add 30 plus 60, 30 plus 60 is 90. Half of 90 is 45. Thumbs up. All right, awesome. Yes, I am kind of going through this a little bit quick. You can pause, you can rewind, watch it over and over again. When you're doing the delta math, oh my goodness, there was an earthquake. Actually, it was just my leg hitting the table. Okay, so go ahead and pause if you want. We're going to take a look at vertices on the outside of the circle here. All right, coming back to you. If a tangent and a secant, tangent and a secant, tangent and a tangent, or a secant and a secant. Sorry about that. All right, so 2 tangents, 2 secants intersecting the circle. Then the measure of each of the angles formed is 1/2 the difference. So again, angle is 1/2 arc big minus arc small. And again, you need to find where the major and the minor arcs, or whatever intercepted arcs are. So I'm going to use what we did previous with the colors. So the smaller of the 2 arcs is going to be red. The bigger of the 2 arcs is going to be green. Notice this one goes, so that point right there, that is the intersection. So that distinguishes the 2 arcs. So difference of those two. Anytime that you have it outside, it's half of the difference. Half of the difference. Okay? So the measure of angle 1 will equal 1/2 whatever my green arc is, subtracted whatever my red arc is. And because they're different letters, I can't put that. Okay? Unfortunately, I gave you all secants. It doesn't matter. Oh, let's do the shortcut, because we did the shortcut up here. What would be the first thing that you do? Well, I had to multiply by 2. So 2 times what that would be the angle. And then if you notice, which one are you going to... Now it depends. You can add the smaller one if you're given the small one. And the small one is close to the angle. Just think about that one. Or it's 2 times the angle. It's, let me think about this here for a second. It's going to be the big minus 2 times the angle. It's going to be big minus 2 times the angle, and I'm going to show you why in just a moment. And that equals the small. Big arc, small arc. Okay? I'll show you that here in just a second, because if I'm looking for the red one, and I multiply by 2 and I subtract the green one over, then I have to get this negative out of there. Okay? So it's up to you how you want to look at it. There's my small arcs intercepted. And then I got my bigger arcs. There, there, and there. Alright, let's do a little formula work here. So the angle, x, is 1/2 the difference. So it's big minus small. Big arc minus small arc. Big arc minus small arc. 1/2 of 98. I hope that's 98. So that would be 49 degrees. Let me just check on my other one that I did. Half of that, yep. Big minus small. Or big minus little. Okay? Alright, angle x is equal to 1/2 170 minus 30. So this is 1/2 of 140. So x is 70. I'm going to change this up for a sec. Well, we're going to solve for x, and then I'm going to show you a different way to do it. Okay, so angle is equal to 1/2 big arc minus small arc. Alright, so angle, oh, it gives me angle, is 1/2 big arc 8x minus 2x. Big arc, small arc, 60 degrees. Big arc, bigger arc, smaller arc. So I'm gonna take twice this, which is 120, so multiply by 2, is equal to, this is 10x. And if you notice, I can take 10 and divide it into 120 12 times. So now if I gave you this, this would be 24, right? So if I wanted to just find out what this was, how would I do that? Well, I'm going to do it a little bit different way. So what I'm going to do is I'm going to take the angle, and I'm going to take half of the big arc, which is x minus 24. Oh, okay, so what do I got to do? I got to double 120, x minus 24, and then I got to add 24. So x is 144. So this would be 144. I'm hoping, well, 12 times 8, Is that right? Was that 8? Yeah, must have been. Yeah. 12 times 8 is 9. Oh, wait a second. Let's pause that for a second. Let me work that out. I got it. Sorry. This is 8x minus 2x, which is 6x, which makes this 20. Yep. So that's null and void. So what we're going to have is this will be 40. Yep. And this should be 160. Yep. So if I take 160 minus 40, I get 120. And then divide it by 2. Okay. So I messed that one up. I added even awesome, super awesome, fabulous teachers sometimes make mistakes for the first time in their career in 2020 during isolation. So I apologize for that. Okay, so let's go over a couple of the problems on the back. The last page, you're going to do the rest of them. I want to get one that has kind of each. I think each one has that. So let's let's do number 9. All right, so the angle, vertex is outside, so the angle is 1/2 arc minus arc. So the angle 1 is 1/2 138 minus 66, which is 1/2 of, yeah, I'm going to pull up my calculator here. 138 minus 66 is 72, divided by 2. Measure of angle 1 is 36 degrees. Okay. Here's one inside. Number 6. Yeah, I think we'll just do these 3. All right, so inside, I don't know if that's the center. So the angle in this case is equal to 1/2 arc plus arc. So measure of angle 1 is 1/2 115 plus 97. So 1/2 measure of angle 1. Let's see here, 115 plus 97 divided by 2 is 106. 106 degrees. That makes sense, right? And this one, a couple ways I can do it. I see that this is given, and that's this arc. I could find what that angle is. So 128 divided by 2, because it's on. So the angle is half the arc. So angle is half the sum, angle is half the difference. So if the arc, the angle is 1/2 of 128, which is 64 degrees. So this angle is 64 degrees. Then I could take 180 and subtract 64 and get 116 degrees, which is going to be the measure of angle 1. All right, so now what I want you to do is come back to me. Hey, I need you to do the rest of that worksheet, and then there is a quiz on Delta Math that you need to complete. This is the last week, so Wednesday you'll get your final instructions about chords and the length of chords inside of a circle. And there's a specific property that goes along with that. You will have your last scavenger hunt. So your last scavenger hunt probably will be doing something with surface area and volume. Okay? So just be aware. And then, yeah, I don't know what else. So have fun. Let me know if you have any questions, and I hope to see you on Wednesday morning. Okay, we'll talk to you later. Bye.